My name is Kendall Roden. I'm a product manager at Diagrid. Prior to joining Diagrid, I worked at Microsoft as a product manager, working on the Azure Container Apps platform, specifically around Dapper integration. So we're going to cover what is Dapper, what is Catalyst. So let's go ahead and get into the agenda so you know what to expect. Before we do, if you're new to Diagrid, just want to kind of quickly introduce the company to you. If this is your first time joining our webinar, we are a startup focused on boosting developer productivity, and we do that by basically building products that help developers build and operate cloud-native applications at scale. And our foundation is really on Dapper, which I've already said a few times. If you're unfamiliar, the Distributed Application Runtime Project is the 12th largest cloud-native computing foundation project and really centers around providing developers with an easy way to build distributed applications. And we'll definitely cover just a brief overview of why you should care about Dapper and how Catalyst makes Dapper easy for you to run and consume. And that ultimately leads to our products today, right? A Conductor, if you're a Dapper user already running Dapper on Kubernetes, we have an operational tool to help you manage and observe Dapper at scale. And then we have Catalyst, which is really for any users who are interested in building distributed applications on Kubernetes or outside of Kubernetes, powered by an open source project, which would be Dapper. So we're going to focus in on Catalyst today. The agenda is pretty basic and pretty streamlined based on the concepts of what today's talk is. So what is Dapper? We'll not spend any more than like 2 or 3 minutes on this topic. Then we'll talk about why Catalyst. So if you're familiar with Dapper, why should you care about Catalyst? And if you're unfamiliar with both Dapper and Catalyst, why should you care about Catalyst? We'll also talk about Catalyst concepts and basics. So really want to start from a baseline perspective. How does Catalyst work? What are the core primitives that Catalyst provides? How can we actually use and consume the Catalyst APIs? And that's really where the API overview and the demos will come in, is you'll have a really good idea of how to use the platform end to end, zero to hero. All right, so let's start with that first question. What is Dapper? Ultimately, I just want to walk through the traditional development inner and outer loop that most of us are familiar with as developers, right? So we have business analysts, we have product managers. I know this because I am one, and I know that I'm constantly bringing feature designs, requests to our backend engineering team. And ultimately, right, developers are going to take these requirements, and the goal is really to build these features so that we can drive business value. So at Diagrid, our goal is to build as many great features for you in Catalyst so that you can ultimately consume it and have a better developer experience. But ultimately, right, the developer is going to take those requirements, do some iteration in that inner loop on their local machine once the requirements have been solidified, and then ultimately going to push that to some type of CI/CD pipeline, which will ultimately produce artifacts, which are then taken by some kind of platform team or cloud engineering team, cloud center of excellence, and they're most likely going to deploy it on infrastructure, right? So this is a pretty familiar process for anyone that's involved in any stage of building software. Now, the challenge is what happens when developers can no longer focus on their core value, which is building features to drive the organizational goals of the company in which that developer works. And a lot of the time now, new complexities have made it where developers don't get to focus on those things quite as much, right? So we have these infrastructure primitives that we have to use to build distributed applications like messaging infrastructure and data storage. And then most likely we're picking some type of runtime platform. And a lot of the time, especially in a world of containerization and distributed applications in Kubernetes, a lot of those details that really affect the way that the application is deployed are bleeding into the inner development loop. So figuring out ways to deploy local dependencies and emulate certain services and emulate certain cloud brokers, all of that has now become a developer concern. And that's on top of a lot of the new paradigms and patterns that have been introduced just because applications are being written in a distributed fashion. So things like handling transient failures and making sure the code is resilient by default, right? There's a lot of new security concerns that developers have to take into account with the addition of a multitude of third-party SDKs and libraries. So as the developer loop gets convoluted with these kind of infrastructure primitives, there are new technologies that need to be created to help tackle this developer problem, so developers can focus on, once again, what they really care about, which is implementing those requirements from business analysts, from product managers, and ultimately from end users. So Now that we've set the scene, basically Dapper comes to help alleviate this problem in the developer lifecycle. So it allows developers to completely decouple themselves from those infrastructure concerns, those infrastructure services through a reliable application level API. So if we think about this, if we look over on the left, let's imagine we have a runtime platform, and in today's day and age of containerization and microservices, Kubernetes has absolutely won in terms of the becoming the de facto standard container orchestrator. And then ultimately, those applications hosted in containers distributed by Kubernetes need to depend on these other infrastructure primitives that we talked about before: databases, key value stores, document DBs, message brokers, secret stores. Dapper provides an API abstraction layer where developers can code against an abstracted pub sub broker, an abstracted database, and the underlying implementation details never lead into the application code. So if I'm on Azure and using Cosmos DB, I don't actually have to consume the Cosmos DB SDK directly to manage that data. Instead, I can use Dapper as an abstracted API layer, call out to Dapper, and Dapper will facilitate the connectivity to that backend infrastructure. So you can imagine this has a lot of really great benefits from a productivity and velocity perspective, but there's even more to it than that. So another good example of this is once we have this unified API layer, let's say we're running in development. We obviously don't necessarily want to be consuming super costly or intensive services in a development interloop. We might want to use like Redis running in a container, for example. So in development, developers can use whatever makes the most sense for them. And then they can basically switch out the backing infrastructure when they move to staging to production without the application code having to change. And as you can imagine, this portability across staging environments can also be relevant across cloud providers. So a unified API, I can use specific services that benefit me on Azure, and then I can move those same applications over to AWS without changing the application code. I can use native AWS services or minimally a least common denominator service like Redis across all cloud providers. So that's really what Dapper enables. And that's probably as deep as we're going to go really to focus specifically on Dapper. Everything from this point on will be really translating how Dapper relates and compares to Catalyst. So I want to kind of talk about why do we want to make it easier for developers to use Dapper? And the reason really is a lot of developers have seen true core benefit in building with this abstraction layer and this API. So we see Dapper, abstracts away the differences in services and languages. It gives a fairly fast ramp up and you don't have to write this infrastructure code. So we see that there's a lot of these benefits. It makes building microservices easier. There's no code changes. There's a consistent runtime. But ultimately, Dapper is still tightly coupled to Kubernetes. So how do we take the benefits of something that's clearly enabling developers to build applications more quickly and bring it to developers running on SaaS and PaaS-based services who are already looking for infrastructure support, right? Infrastructure platforms that don't require a lot of overhead. How do we make it easier for developers to also benefit from Dapper in these scenarios? So that's where we get into why Catalyst. So ultimately, this is Dapper running on Kubernetes. You have an application talking to its Dapper sidecar running in a shared pod, if you're familiar with Kubernetes. But if you're not, that's great because this part is for you. There's a lot of developers that aren't, right? We see a huge adoption of serverless platforms. A good example of this being Azure Container Apps, right? I was a product manager at Azure before I joined Diagrid, and they built Azure Container Apps to help alleviate the burden of talking and managing Kubernetes directly, right? So removing direct access to the Kubernetes API server while still giving developers the ability to easily deploy applications on top of scalable infrastructure. So we're seeing serverless adoption continue to rise. We're seeing Kubernetes continue to go under the hood. And there's a constant slew of serverless architectural patterns, practices, architectures that you can find on any of the major cloud providers that indicate to us that developers are continuing to trend towards platforms that lower their operational burden and help them to be productive quickly. And that's really where Catalyst comes into play. So Catalyst is really Dapper beyond Kubernetes. your code can be hosted anywhere. We're talking any AWS Lambda, Azure Container Apps, GCP Cloud Run. The limit is it does not exist, right? The runtime platform is truly up to your team, what works best for you, and what ultimately is best for where that solution should be hosted, whether the packaging format is containers or just a process. And then instead of calling to a sidecar running in Kubernetes, you're calling out to a SaaS-based platform that we're hosting at Diagrid called the Catalyst Developer API platform. And this API platform has a set of consumable APIs that help you build and author distributed applications and essentially connect services running across cloud providers, across platforms, while still getting the benefits of that single standard API layer. Today, we have 5 APIs in Catalyst. We have workflow, PubSub, service invocation, state management, and bindings. And then we provide you some cross-cutting concerns on top of those things, like implementing resiliency on the API out of the box, implementing access control lists for service invocation, getting a full end-to-end visualization of your applications as they communicate using the APIs, and then providing obviously things like API observability via logs and metrics. And then another really cool thing that Catalyst provides is 2 managed infrastructure services. So let's say that you want to have a couple of applications that are communicating via a PubSub broker for asynchronous communication. Instead of going out and deploying your own message broker like an AWS SNS SQS or Azure Service Bus or even a Kafka, you could use the built-in Diagrid PubSub broker, which is basically deployed in a single line and then provides you with an out-of-the-box way to test the APIs, and all of that is available to you as part of the platform. And then same on the state management side, if you needed to use key value storage, you could use the one baked into Catalyst as an infrastructure service, or you can obviously bring your own. So that existing infrastructure concept totally still exists. You can use Diagrid services, you can use Azure, AWS. We make it easy for you to onboard existing infrastructure that's going to be driven through these APIs. All right, awesome. So once again, not only do you have this API abstraction layer, you still get the benefits of Dapr where you can bring your own infrastructure brokers, and we'll talk a little bit more about that and see that in action today. So as I mentioned, just want to reiterate this, Dapr, when you're managing it yourself, is typically running as a sidecar in Kubernetes. And so your application is communicating to that sidecar over a local host. And then on Catalyst, you still have your application code. You're still using the core Dapr APIs. You can still use the existing Dapr SDKs that are tried and true and adopted by thousands of developers. However, you're now calling out to what's called a Catalyst application ID, which represents that remote hosted sidecar. So the API calls will look slightly different, but still very much the Dapr APIs. We see here on the left, when we're calling a Dapr directly in Kubernetes, we're using this local host 3500 to indicate where the Dapr sidecar is running. However, when we flip over to Catalyst, we now see that there's HTTPS because this is obviously encrypted via TLS when you're calling out to these remote APIs. And then you have a project URL. So that project URL is going to represent the ingress point through which your requests are then forwarded to the appropriate app ID. But ultimately, everything from a Dapr perspective, that v1 invoke, v1 state, v1 publish, these are the APIs you'll be calling in order to leverage the capabilities of the Catalyst APIs, which are ultimately powered by open source Dapr. So Catalyst makes it really easy to get up and running. And like I said, this next section, we're going to dive into the nitty-gritty of all the concepts you need to know to be successful when building applications using Catalyst. So the first step is always going to be creating an application ID. And you really should think of this as almost being like an application twin, or for every microservice that we have externally, we're going to have an internal Catalyst app ID. And think of an app ID as being like akin to an API token. So it's a unique way that you can essentially allow an application to access certain resources, perform certain functions. So that application ID is quite literally an identity which an application uses to communicate to Catalyst. So once that app ID is created, you can then create infrastructure connections. So you can do this using the UI, the CLI. You can even import existing Dapr manifests if you already are familiar with Dapr and have Dapr manifests available. But ultimately, what this is going to do is establish connectivity between the Catalyst APIs and the backing infrastructure. So you can imagine this makes it really easy for platform teams to onboard new infrastructure that can be easily consumed by Dapper developers that are calling out to these APIs. And in addition, you can create security primitives that lock down the APIs that have access to, the app IDs or the API tokens that have access to given infrastructure services. And then last but not least, you can basically invoke the API, right? So I have my app ID, I have my connection. Now I just need to have my application. So that application is going to call out using that project endpoint to whatever API it is making use of using the existing Dapper SDKs. So for example, the V1 state API will call out to the Catalyst project. It will use the API token for its associated app ID, and then the app ID will broker and facilitate the connectivity to DynamoDB in this case. So there is no AWS code in your application. I want to make that very clear. There is no DynamoDB or AWS specific code in your application. All of that is completely removed from the developer point of view, which makes it easy to swap out these backing infrastructure resources as needed. Whether you're doing multi-cloud or you just want the flexibility of choice, which is always nice. Catalyst is really taking Dapper to the next level and enabling new Dapper use cases for developers, not just on Azure, but beyond that, right? So you can streamline and future-proof your application code, which has always been a nice benefit of the Dapper project. You can then connect apps across programming models, packaging formats, hosting platforms. So you really now have the true option to plug and play cloud resources and build your own service and your own platform that's kind of an amalgamation of what makes the most sense for your distributed solution. And then once again, we've emphasized this already, but I can now talk across 3 different serverless platforms on 3 different cloud providers through a seamless API surface, which makes multi-cloud scenarios extremely viable. And another thing we've seen a lot of developers doing as well, who maybe are familiar with Dapper, is, hey, Dapper exists in the context of a Kubernetes cluster. How can I get Dapper to communicate from one cluster to another? Catalyst now enables that bridge, right? I can have a service in cluster 1 calling out to a service in cluster 2 using the same Dapper API surface and leveraging Catalyst to do that. So let's get into the core concepts, the basics, make sure that everybody truly understands the core primitives of Catalyst. First and foremost, I just want to highlight the 5 available APIs in the Catalyst developer API platform. One is service invocation. The big goal here, how do I communicate synchronously from one service to another, regardless of where it's hosted, using either HTTP or gRPC? That is available to you today. We have publish subscribe, which is asynchronous messaging between 2 or more services using some type of broker. We have state or a key value, which essentially allows you to store a key value pair from a service and retrieve that, manipulate it, so on and so forth. We have bindings, which work with essentially external systems as either input or output. So think of this very much in the serverless paradigm. You have the concept of bindings, which can either trigger the function to start or be triggered as a result of the function processing and maybe storing something in a downstream system or another service. We have those available in Catalyst today. And then we also have support for workflows. So this is definitely a really compelling API use case. A lot of developers have to build these distributed applications that essentially have business logic distributed across multiple servers potentially or multiple platforms. So to have one way of essentially authoring a workflow, which can be executed in a particular sequence, and then storing the state, allowing that state to be replayed in the case of transient failures, allowing that workflow to potentially run based on waiting for an external event that might take anywhere from 5 minutes to a year. All of that is available in Catalyst, and we'll dive deeper into that when we get into workflows specifically. Another core concept here, and I kind of mentioned this, right? And I just want to reiterate the 2 main concepts you need to be aware of: application IDs and connections. So your code is running on your compute. You're completely responsible for deploying your applications. However, the Catalyst responsibility will be to host those application IDs, which are essentially API tokens through which you can call the APIs. And then the backing services you want to use, totally up to you, your provider, your cloud service. However, you will have the concept of a connection, which is ultimately going to be brokering and facilitating connectivity from Catalyst to that backing resource. This is going to look a little bit different when Diagrid is hosting the infrastructure, but once again, we'll get into all of that here in a bit. Another really critical thing that's worth calling out is the concept of application connectivity. So there's two types of requests that you can make in the Catalyst platform. So one of them is simply a request. This is going to be what you would traditionally perform as part of a SaaS-based offering. So for example, my service A is a Java application running on AWS App Runner. I'm going to call out to the APIs using that project URL, providing the protocol, either HTTP or gRPC, and then using a secure API token. So I'm going to use this approach when I want to do things like publishing messages or triggering output bindings. If I want to invoke another service or manage state, if I want to run and execute a workflow, all of that is happening on the request path. Now, there's also the concept of an outgoing request. An outgoing request is involved and required when Catalyst needs connectivity to your external workload. So for example, I have an incoming request when a message is published and an outgoing request when the subscriber needs to receive that message. So think of it as being a way for us to forward any incoming requests that need to be destined for another application. So for example, triggering an input binding. If an input binding, for example, a new blob is created and I want my application to take action based on that binding, I need to be able to call out to your application in order to tell it that the blob arrived and that the work should proceed. And then when an application is the receiver of an invocation request. So this is going to require two specific things: an app URL, which is essentially where your application is running, and an app token will be generated. So that just makes sure that that's secure, and you can obviously validate the app token as it arrives to your application. Now, one of the big questions that's likely to come up here is, how do we do connectivity securely from our platform to yours? Today, there are two ways. You can establish a private tunnel using our, a Catalyst tunnel that we essentially allow you to deploy alongside your code, or you provide a public endpoint. Now, obviously, that's probably not going to fly for a lot of scenarios, right? You're most likely going to have private applications on your own VNet. This is something that's currently in progress. We're working to implement, and inevitably will have in the next several months the ability for you to set a private endpoint, which would mean that we essentially communicate privately over your cloud network to ensure that you don't have to open a public endpoint. So that's just something to be cognizant of. And then last but not least, I think I touched on this pretty well, but the other concept, this connection concept, what you're going to provide when you create a connection is authentication details. So how does Catalyst authenticate to your broker or your state store, and then any additional metadata configuration. So this can be things like that are very specific to a given broker or a given state store. So it might be things like time to live, right? You might want to set specific time to live on a given state store. You can do that through this additional metadata configuration that's in the connection resource. We have over 30 supported connections today. So pretty much all of the major infrastructure resources that are being used by developers or platform teams are supported in Catalyst. And once again, if you have any interest in seeing more of those, we'd love to talk to you about, adding some connections. Another call out here, long-term today, the way that this will work, when you provide us authentication credentials to talk from a connection to your infrastructure, those are stored in a secret store and encrypted. However, long-term, most likely, it would be nice to not have to provide secrets at all, right? And that's something that we're working on as well. So essentially allowing you to grant access from a Catalyst identity in your particular identity provider, which would remove the need for you to pass in any secrets to us at all. So that's really our goal, is to make it where the connectivity between both applications and infrastructure services is completely private to you. So this is what we see in like a traditional event-driven architecture, right? We've got our publisher, we've got a pub sub broker, the code's going to be directly in our application, and then we have subscribers that are subscribing directly from the application code. If we put this all together, everything we just talked about, we'll now have a publisher that posts to the API endpoint in Catalyst. that application ID will then take that insight or that request and forward it to the pub sub connection. This pub sub connection is going to be the representation of your underlying broker, and then it will deliver that to your subscribing applications through their respective application IDs. And obviously, this allows for a lot of operational flexibility because you can now decide what that pub sub connection points to, whether it's GCP pub sub, Redis, and all of that can change. Your application developers are completely shielded from this, making the code extremely streamlined and a lot more secure. So let's start with service invocation. This is the first API we'll cover today, but we'll cover all five. So the service invocation API essentially is to empower, like I said, synchronous communication between services. And through Catalyst, these services can be running anywhere. And really the only thing that dictates that where the request is sent is that application endpoint that you set. So you can invoke either HTTP or gRPC services using this consistent API standard. You can configure resiliency policies on the service invocation API, and you can also do things like setting access control policies to ensure that only specific applications have access to target others. So we'll do a quick demo and kind of show all of these features in just a few. So this is what it looks like in practice. Once again, hopefully this feels familiar and the concepts are clear. Let's say we have an application written in .NET running anywhere. Let's just say it's running in Kubernetes in this case. That application is calling to an app ID through the this post endpoint. So we see it's going to have the Catalyst project URL, the invoke endpoint. It's going to it's going to pass in a target method. So what method am I targeting on the service, and what application am I targeting? So you can see we're invoking the target app ID on the method my method. So that request goes to Catalyst. Catalyst then makes sure that it is resolved to the app ID of the target, which in this case is here. And then that target application, depending on its endpoint, will forward that request to the my method endpoint on the target application. And in this case, the target application can be written in any language, right? We're completely agnostic when it comes to languages, frameworks. It should work across any platform. So all of that is really up to you. You get a lot of freedom and flexibility there. The big thing that you need to be aware of is that you need 2 application IDs and that you need to specify the method on which the target application will be invoked. So I'm going to show you this is how you can get up and running and started with invoking an API. And this really applies to most of the Catalyst APIs, but we're going to do it in the context of service invocation just to get you familiar with the platform. So one way is you can use a CLI emulator. So let's say that you have not deployed any applications on any platforms and you just want to test out the service invocation API to see if it works. We have two really cool CLI commands. One of them is a Diagrid listen. What that's going to do is basically open a local stream on your in your CLI or your terminal, which will essentially wait for any incoming invocation requests on an emulated app. So you can say, oh, I want to listen on the app ID target. Obviously, there's no code behind this, but I want you to display if a request comes through to a specific method. So you can basically just get up and running, test it out without deploying any code. And then you can use the Diagrid call invoke method to essentially emulate calling the APIs without actually writing any code. The second option is you can use a combination of these things or just specifically use the API Explorer. So in the API Explorer in Catalyst, you can essentially pick an API, you pick the API token or the app ID. Once again, those are basically synonymous that you want to use to make the request. And then you choose what request you want to send and click test API. So this will allow you to test the API without deploying a client application. And in this case, you can use the Diagrid listen command to receive it, or another, you can have a listener already deployed with a different app endpoint on a different platform. And then last but not least, once we get beyond kind of the testing phase, learning phase, you can obviously use the Dapper SDK, or you can use just plain HTTP or gRPC to invoke a service. And that the service that's being invoked really doesn't have any specific logic in it at all. All it has is the receiving method. So that method will look exactly like if you were just writing another, a method in an application that you were going to eventually invoke via some type of endpoint. It's just a REST endpoint. There are no other dependencies. And really the only thing that specifies which method is getting invoked is going to be that API call made from the invoking service. So I'm going to stop talking and I'm going to show you a couple of these in practice just so that you get a little bit of familiarity with how all of this works. Hopefully now you can see the Catalyst platform. This is the UI. And you can see I already have a couple of app IDs created. Once again, you can use the tool that makes the most sense for you when it comes to interacting with Catalyst. If you are a CLI person through and through, you basically don't need to go to the UI at all. If you're a UI person and you don't want to use the CLI, there's very few things that you have to depend on the CLI for. So what we'll do, we'll just create a new app ID just for fun, and we'll call it invoke test 2. Now, the reason I'm starting with an app ID is because the application ID provides me with that API token. So in order to invoke an application, I have to make sure that it has an associated app ID. And then maybe what we can do here is we'll just use an existing application ID to invoke test 2, or we can create a new one. So we'll call it caller. So we'll create those app IDs. And one of the things to note too, when you're creating an app ID, there are a few settings you can configure. So one, you can connect to an existing application. So like, let's say you already have an application running on Cloud Run and you already have the endpoint, you can go ahead and drop that in here when you create the app ID. But if you don't, that's okay. You can add an endpoint after the fact. And then you can also add a couple labels. These labels just kind of are good for making sure that you know what this app ID represents and where the application is running. So for example, if it's running on Azure, you might want to tag it with Azure, and then we allow you to add, your own labels, which just help from a grouping and sort of visibility perspective. So we can see that our two application IDs are ready to go. Now, remember, this invoke test doesn't have an app endpoint. So I can't invoke something that doesn't have an endpoint because I wouldn't actually be able to see any requests come through. So what I'm going to show you is how you can use Diagrid, the Diagrid listen command. But what we're going to do is we're going to do a Diagrid listen, and then we're going to pass in an app ID. And I want us to remember, so what app ID we want to listen to is the one that's going to be invoked. So it was invoke -test 2. And then we want to listen to any requests that come through on the endpoint, invoke new orders. So this can be an arbitrary method. You're just testing to make sure that the API works. So we're going to set up Diagrid listen. What this is going to do, it's going to create a local tunnel from your app ID to your terminal. So this allows this to basically emulate the server-side application that would be receiving invocation requests. So I don't have to deploy an app, but I can start invoking this app because I'm emulating it here in my terminal. So what's happening in the UI as this is being, it goes into processing, and what's happening is it's establishing this app connection. This app connection right now to my local machine is allowing for that invocation request to come through. So we'll give that just a second. It'll flip into ready. And then what we can do here is we can either use the API Explorer or the Diagrid call command to simulate the invoke, to simulate the client application. So we can select the invocation API, and we'll use the caller because the caller API token will call into the service, and we'll forward the request onto the target application. So we'll do a, let's say, post, and our target application ID is going to be this invoke test 2. The only target applications that will show up here are ones that have an app endpoint. So we'll click invoke test 2, and we're going to pass in that method, which I believe was invoke new orders. And then I can pass in, once again, arbitrary piece of data, because all I'm trying to do right now is show you the request itself. So you can see here, I have a curl request, and it's formulated for me. It's hitting that project URL, which I can find up at the top of the page as well under HTTP URL. It is calling the V1 invoke API. It's invoking the app ID invoke test 2 on the method invoke new orders. And you can see here, I added an extra slash. So we'll fix that and we should be good to go. All right, so let's go ahead and test the API. And what we see is we got a status 200, which means it was successfully delivered. And we can see that our emulated app received the request. So what would your next step be from here? Actually receiving the request from code, right? So what you can do in order to move to that next step is you can configure the SDK in the language of your choice. So you can add this to an existing Dapper application, and then you can, or excuse me, an existing JavaScript application. And then you can essentially use these code samples to copy and paste what it might look like to invoke an application. And you can see it populates here with the information you passed in. So it's going to invoke test2 on the post and perform a post. And then you can see here that we have the order ID and the headers that are required. And the API token, once again, that's how we are validating the request in Catalyst, is through that API token that is assigned to an app ID. So it makes it super easy for you to basically go from trying something out to actually implementing it in code. Fairly simple, right? And once again, this invocation target, yes, right now it's our local host, but we could go in and update this app connection to point to a Lambda resource to call out to a container app, to call out to an application hosted on a virtual machine, right? So all of that is completely up to you. And we can also check out the API logs. So what we see is two things, which is exactly what we expected. We see the request. So the request made by the caller to the invoke test2 application ID on the invoke new orders endpoint. And we can even see this one was made from Chrome. So we can see that we used the API Explorer to make that call. And then we can see that the outbound request was forwarded to my local machine on invoke new orders. So all of that worked. It's exactly as we expected. Kudos. We love when a demo comes together. So that's just a quick example on how that works. Now I want to show you another just quick cool feature specific to service invocation. So what I'm going to do here, I'm going to go ahead and stop this application. And what this does when you do a control C, it still leaves your tunnel open. So if I do a Diagrid dev status, you'll see all of the open tunnels to your machine. The reason the control C doesn't kill the tunnel is just for quicker iteration, right? I can leave the tunnel open, I can restart it, there's no load time. So it makes it super easy. So if I want to stop this, I can do a Diagrid dev stop, and I can explicitly tell it that I want to stop the dev tunnel for the invoke test2. So what this is going to do, it's going to remove the app endpoint. It's disconnecting. Great. So I mentioned one of the cool things that you can do in Catalyst as well on the service invocation API is set an access control list. So what this means is, what if I don't actually want the caller to have permission to call invoke test2? I might only want the publisher to be able to call it, for example. So to be able to specify which applications have permission to invoke a certain app, you can use the Diagrid app ID trust command. So in this case, we're going to change this here to invoke test2. And what we're saying is, I only want to trust a subset of apps. So allow invoke from. Let's go ahead. We'll put caller in as the invoke from. Let's do caller. And then we're going to try invoking it from another service, and we're going to see it fail. So let's go ahead and run this. And we can do a Diagrid app ID trust get. Oop. So what I'll see here is that only the caller app ID can invoke test2. So I'm going to do a Diagrid dev listen, or excuse me, a Diagrid listen. So we're going to reopen that connection. We can see it's connecting. And we'll go back here. And we'll see that invoke test2, once again, we're getting that app connection reestablished since we did a Diagrid dev stop. And what we're going to do is we're going to try calling invoke test2 from any of the other application IDs that don't have permission. And what we can see here, by the way, is the application graph has populated. So I can see that the caller is making a direct invocation request to invoke test2, and there's no component here, right? So there's no component in the middle, but we can see if there was an error rate or specific latency, if we were running multiple requests, right? I've only made one and it was successful. But you know, the app graph basically gives you this visualization. So for example, if we were looking specifically at like PubSub, we would actually see the PubSub connection in between and be able to see the error rate from the publisher to the PubSub and the PubSub to the subscriber. So that subscription delivery, that outgoing request. So, okay, let's go back and let's try this out. So we know that the caller should be able to invoke our local service, and let's make sure that it's connected, which it is. So if we go back here, we'll go ahead and we'll invoke it with, you know, a quick test. And this should go through with the 200. Awesome. So now let's try it from another application like invoke test. We'll do a get, we'll target the invoke test, and we'll do it on invoke new orders. So if we do the test API, what we'll see is permission denied, right? access control does not allow this application to, to this particular SPIFFE ID, which is how we do application identities. And you can see invoke test is not allowed. So just a quick example of how you can add additional kind of capabilities on top of some of the APIs. Okay, another quick thing to call out here, the PubSub API. So you can integrate with a ton of different message brokers and queues. You get guaranteed at least once delivery using the PubSub API. You can use declarative subscriptions. So this keeps all of the subscribing logic out of your code, which means you can easily add new subscribers without any code modification. You can also specify content-based message routing. So you can specify either a default route where the message goes, or you can get even more specific based on the content of the message to route it to specific places. You can create dead letter topics and set resiliency policies. And then you can also, once again, limit access via scopes to ensure that only certain applications can make use of a given PubSub connection. So in Catalyst, the way this works, we've got our producer. The producer that you're running wherever it's hosted will make a request using the API token for its app ID. It will then make use of the connection that's specified in the API call. And then it will be forwarded, that message will be forwarded or delivered to the path via the outgoing request. So in this case, whatever is subscribing to my app, new orders is the topic. So it'll publish to the PubSub broker, PubSub on the topic new orders, and then ultimately a subscription will dictate what route that goes to, if it's using content-based message routing, those kind of things. And yeah, it's as simple as that. Let me see. So yeah, this is just an example if you were using like an app runner instance. So I have my publisher publishes to the Catalyst platform. And in this case, let's say it's using a connection called AWS PubSub and a topic called orders. So the PubSub connection will basically be named AWS PubSub and will have the AWS credentials needed to talk to AWS SQS. And then what's going to happen is you're going to create that subscription resource, and the subscription resource will essentially dictate which application IDs receive the message. And then depending on the app endpoint of the subscriber, the message will be forwarded. So in this case, it could be an app runner instance. It could be Lambda. Once again, the choice is up to you. So let's see PubSub in action, and then we'll kind of do a quick rundown of the rest of the APIs before we close out. So we'll go ahead and we'll stop this. Do a quick, do a quick clear. Okay, so I have a couple things to show you here. So one is I already have a publisher and subscriber app ID that have been set up. And if we take a look at maybe the past hour, we can see it's been, I guess, longer than that since I made some requests. So we can see that I've actually already been kind of generating some load on the PubSub API. And we can see that we also used the service invocation API when we were just testing out the API Explorer. If I click in on a particular API type, I can also see the connection it's using. So in this case, it is the PubSub connection and the orders topic. And then I can see more in-depth observability using the metrics tab. So we can see latency that was coming through on the various requests that I have. I can see the requests per second. And then I can also see that I tested out a PubSub broker that didn't exist, and that I was able to see that error rate because I was essentially posting on an endpoint that was not valid. And then the other thing, I think I've already showed you this, but if we take a look kind of at the broader set of API logs, we can see some failures were coming in, right? So we can see we get some detailed information when we're making failed requests, like 404 not found, PubSub failed, PubSub is not found. Well, why was it not found? Great question, because it didn't exist as a connection. So the connections completely dictate what the API calls can use to, as their backing targets. So in this case, we're actually using a PubSub broker that's managed by Diagrid, which is hosted under the Diagrid services tab. So you can see here, I have a PubSub broker. I can go in, I can see the topics that exist. I can see that there's a subscriber there. And then obviously as messages are coming in, I'd be able to see that detail as well. If I want to create a connection to another resource, I can do that easily using this connections concept. So for example, let's do a PubSub connection of type Kafka. I can then restrict who can access it. So we're going to say just the publisher and subscriber, since they're the only ones using the PubSub API. And then I can pass in an authentication profile. I can say SASL, where I have a username and a password. That's what we're going to use in this case. So I already actually have a Kafka broker that is up and running. So let's go ahead. This is called Upstash. It's a serverless Kafka broker. I can go ahead and put in my username, and I think that's the username. And I can put in the password. Copy the right things here. Awesome. So I should be able to then click continue. And I can call the connection, let's say Kafka Upstash. And brokers is going to be that endpoint for our actual Kafka broker. So we'll go ahead and push that in here. And then you can see I can pass in other metadata, things like an offset, if I want to disable TLS, if I want to set a particular consumer ID. So all of that is completely optional and up to you. And then I can also set resiliency policies. So if you want to see what the resiliency policies are by default, you can click this info button. These aren't configurable right now. However, long-term, the goal will be that we allow you to set more configurable resiliency policies, but you can go ahead and enable or disable these. For inbound, that means when publish requests are going into the broker, and outbound would obviously be for delivery to the subscriber if the subscriber is failing. So we'll go ahead and click continue, and we'll save this. Hopefully I did this right. I didn't practice one before, but you can see it's really easy to basically go in and create a number of different kinds of components, and then you can use those as a target in the API calls. So you can easily swap those out. Application code stays the same. You can test them with the API Explorer, all of that fun stuff. So I want to show you another really quick thing here. I have my publisher, I have my subscriber. That's all great. I have my PubSub broker already available, which we saw using these connections tab. And yeah, it looks like we got an error. I think I probably used the wrong information. So forgive me for that. But we can see we have an error, so I could make a modification to that. But ultimately, you get the point of being able to go in and create an external connection. So we're going to go ahead and use this PubSub broker that's managed by Diagrid. And we've created a PubSub subscription. So I mentioned the PubSub subscription dictates who receives the messages. So we can see the connection that we're targeting is PubSub. The topic is orders. The route, the default route, is going to be PubSub new orders. And the app ID, which is scoped to this, is going to be the subscribing app. So I want to show you in the application code here. And we're probably going to finish on this demo, and then we'll do a quick wrap up. Just give me 1 second. Trying to pull up another screen. That is not it. If I swipe up here, there we go. Okay, cool. So what I want to show you is how easy it is to get up and running with actual code. So you can see here, I have a JavaScript PubSub example. This is one of the quick starts that we provide out of the box. And all the code does, the publisher goes in, sets the Dapper API token, which we mentioned, and it's going to make a publish request on the PubSub name, which in this case is PubSub, which corresponds to our connection, the topic orders, and then it's going to pass in a payload. And then the subscriber app, all it's going to do is have that PubSub new orders endpoint. It's not making any requests. It's just receiving requests to the PubSub new orders endpoint. So what I can do is I can do what's called a Diagrid dev scaffold. So if you do a Diagrid dev scaffold, what this is going to do is create a dev config file for you. So in this case, you can see dev API demos updated because I've now added new app IDs. Like if we take a look here, we can see what it does is it pulls all of the app IDs we have available. It wires up all the environment variables and allows us to pass in a port, which is going to establish a local dev tunnel to our machine. So in this case, we could actually remove these app IDs because we're only using the publisher and the subscriber. And you can see I've already updated these. The nice thing about the dev config file is it's incremental. So if you make updates, those will stay and it'll just add things that are new. So I'm passing in an app port because I want the subscriptions to be delivered to my local machine. And I'm passing in the necessary information from a publisher perspective to connect to Catalyst. So let's do quick test. We're going to do Diagrid dev start. What this is going to do, it's going to run both of my applications. Oop, I think I may already have it. Yeah, I already have it running. My apologies. Let me do let's see. This is on me for testing before. And then I'm just going to kill the app because it's probably still running on my machine. Cool. So let's try that again. The port's not taken. We should be good in this case. Okay. So we're going to click allow, click allow. So what we can see is that it is running both of our applications. We can see that server is listening at 5002, and then it connected to that endpoint on my local machine. And we can see that the subscriber is officially connected. So what's going to happen, fingers crossed, I'm going to start publishing messages from my local machine to Catalyst, and then Catalyst is going to deliver them back to my local machine to the subscriber. So let's do a quick test. Once again, holding my breath here because once again, demos are never fun live. And there we go. So we published data and received data. We deployed no apps. We made very little code changes. We have no infrastructure primitives in our code at all. And we are easily able to get up and running. I can send 1 million of these through. And what we'll see if we go back to Catalyst, we'll see that our pub sub broker, we can see the subscriber is consuming all the messages. So the message count is 0, which means it's consumed everything there. We can see the API logs that we clear this out here. We can see that the publisher sent a request, the subscriber received an outgoing request. And once again, I fumbled the bag on this particular part, but what I could do is I could completely change the way that my application is connecting to infrastructure by simply going into my publisher and changing this environment variable to point at a different connection. And we would expect the same exact behavior. So super cool. We only have 2 minutes left and we have 3 more APIs. I have a strong feeling we're not going to get through all of them, but we can at least do a quick little rundown, and I'll obviously send out this deck and more as so that you can leverage it. The big thing here, state management. What's really cool is I believe I already deployed a key value store here. I didn't. What I'll just show you is I can create a KV store. And once that KV store is ready, I can simply start publishing things to it. So I can go to the state API. I can pick any of the application IDs. I can pick color, and I can basically test what it looks like to interact with this, right? I can say my key is maybe 1, and the value is going to be like maybe this would be order ID 1. So maybe it'd be like, I don't know, grapes. Let's just say that. So I'm going to make this call directly to the connection. Now it may not be ready yet. We'll go ahead and test it out. Yeah, so we can see here, state store is not configured. Most likely it's because that connection is still being provisioned. The backing infrastructure is still being provisioned. Oh, we see it's ready. Fingers crossed. Let's try it again. Who thinks we can do it? It'd be a cool way to close things out. Let's see. Test the API. We get a 204. We go in. We can see very quickly that our data was stored, which is awesome. And the other APIs we didn't cover today is basically bindings. I have really great content here that you can take a look at, but it's going to work very similarly, follow the same model. You're ultimately creating a connection, hitting the endpoint, and you're off to the races there. And then another really compelling API, which is my personal favorite, is workflows. And we'll actually do a deep dive on workflows in the coming weeks. We might even do some of that on the next webinar since we've covered some PubSub today. But essentially, you can go in and create a managed workflow in Catalyst, which is super awesome. So we have a workflow viewer where you can actually go in. You can enable managed workflow on your project, which means we'll completely manage workflow state for you. And then you basically begin calling the APIs and it will show you all of the workflow running, and you're off to the races once again. So that's kind of a rundown of all the APIs. Hopefully what I covered so far was valuable to you. And once again, we'll go ahead and cover workflows next week for those of you joining the series, just so you can see all the great newness of the Workflow Explorer. Another thing I wanted to call out, we are doing a Catalyst hackathon. There is a prize pot of over $5,600. The grand prize is $2,000. You can win bonus prizes of $500. So it's definitely worth checking out. If you're interested, you can go ahead and scan this QR code, but you can reach out to us directly as well. We want to see what you can build on Catalyst. You'll get a free AWS sandbox. You'll get a lot of goodies. So we'd love to see you there. And then ultimately, if you haven't already joined the Catalyst Early Access program, please sign up. Please sign up. We would love for you to play around with the product and give us feedback. But yeah, I hope you feel more confident in the Catalyst concepts, Catalyst APIs, and how you can potentially get up and running with them.